This talk is part of a series presented by the TechAide AI4Good conference and hackathon. Our goal with this virtual event is to highlight technological innovation driven by AI and directed towards beneficial areas such as health, the environment, accessibility, and human rights. Importantly, we also aim at raising money for TechAide, a nonprofit dedicated to fighting poverty and social exclusion. And this is where you can help. Please consider donating by clicking the corresponding link in the description section of this video. Any amount will be greatly appreciated. Also, if you are watching this before November 12, 2020, consider registering to our event for a chance to ask questions and interact with our great speakers. This event would not have been possible without the help of our sponsors such as DeepMind, Ubisoft, Ivado, and Dell Technologies. We thank them for their generous support, and please visit our website for our full list of sponsors and partners. Particularly, we'd like to highlight our gold sponsor, CDW. Proactively mitigating risk will never be easy. It's ongoing, it's daunting, it's confusing, but it's not impossible. Let CDW and Dell help you with a solution to keep you protected. With 24/7, 365 Security Operations Center, they are well equipped to keep your organization safe. And with that, we'll leave you to our feature presentation.
I'm going to talk about the importance of mining connections to understand complex societies and markets. Let's start with why mining connections. Basically, connections are in almost all natural and applied sciences. For example, in natural sciences, you can consider how atoms bind together, how proteins interact with each other, and also we can consider the cosmic web. One important property of these interconnected complex systems is that they are not simply aggregation of their individual parts, and when we look at them at the system level as a whole, they give us non-trivial insights which cannot be achieved otherwise. This is much more relevant today than before because our world is becoming really interconnected, and we do need a good set of techniques for analyzing interconnected data to be able to study today's world phenomena and also today's world's emerging problems. We are going to give examples of these later in the talk. But before that, let's start with a very short background on what actually is mining connections. So it is analyzing data where instead of independent instances or data points, we have interconnected instances. More specifically, we often deal with a data set that is represented as a feature matrix, where you have instances that each are represented as a feature vector. But in this case, we are given connections between these instances, which you can consider as a graph. And these connections are often time dependent, and they change the features of the instances. And the features of the instances would change or affect the networks of interactions. To give a more concrete example of what this means, consider a society where we have individuals and the friendship would be the connections between them. We know that in a society, there is social influence and social selection in place, which means that you tend to befriend people that are similar to you, which is connections being affected by the features, and also you tend to develop interests or features that are similar to what your friends have. Right. So it's important to consider the connections and features at the same time, because there is this feedback loop between them, not only in the social in a society, but in general cases, it's a property of complex systems. So Speaking of the complex systems, let's look at who is doing connection mining. So basically, I want to emphasize that this is a very multidisciplinary field. We have researchers from a lot of different fields, but most notably, the complex systems have been the focus of physicists for a long time. In sociology, social networks have been present for a long time, and actually sociology from the early on when the field was defined was focused on having this holistic view and looking at a society as a whole. A lot of techniques that people or researchers use for mining connections are rooted in graph theory mathematics. We have the graph mining community in data mining, and in machine learning, we have relational learning models, and also more recently, we have graph embedding and graph neural networks, which are more on trend now. And there is also a umbrella term for the researchers that do connection mining, which is basically network science or science of networks. My group is focused on developing techniques that could be used to analyze interconnected data based on the needs that we observe in AI for good applications. And in the rest of the talk, I'm going to talk about 3 of those applications. Basically, in all of which, the key to solve the problem or understand the problem is looking at the connections. I'll start with modeling COVID by incorporating interconnected populations. The second application is uncovering organized crime rings by finding hidden connections. And the last one is detecting coordinated or polluting groups in social media by looking at the interconnected discussions that we have online. Right, so the first application is on modeling epidemics based on a more realistic contact network. So what I mean by that is that often the models that people use for epidemic modeling are fall into the compartment-based category, which are these models that you have you divide individuals into different components, and they come into contact with each other at random. Basically, anyone that is infected could infect anyone in a susceptible group. What we observed here is that this random structure assumption is actually changes the epidemic curve. So more specifically, we modeled the epidemic on top of a graph structure, which shows how people come into contact with each other. And then if you give it a random graph, it would be exactly the same as the compartment-based model, but it's flexible and you can plug in any other proxies for what is the actual contact network. In particular, we looked at the real-world graph, which is extracted based on connections to a public Wi-Fi hub in Montreal. So basically, if people connect to the same hub at the same time, they are in close contact with each other, and there is a link between them. What we show is that the structure that you assume for your contact graph changes significantly the curves that you observe for the disease. It changes significantly the effectiveness of different NPIs or interventions that you take, and also changes the outcome of reopening strategies. So it's important to try to incorporate more realistic assumptions on the contact graph. To look at the more concrete example again, here we have the result of the curves as a result of applying varying mask NPI. And you can see the final attack rate. So basically, how many people were infected by the end of the epidemic. And what we observe is that with the random graph assumption, you don't see much drop in the overall number of people that get infected, which corresponds to actually this flattening the curve diagrams that we have seen everywhere, which says that let's just delay the peak. But at the end, the area under the curve is the same. Everyone would get almost the same number of people would get infected. Whereas if you change the underlying structure to something more realistic, similar to the Wi-Fi network that we used, you actually see a significant drop in the final attack rate. Similarly, if you look at the reopening strategies and compare the same simulation, we are only changing the structure of the underlying contact graph. The random graph underestimates the result of reopening hubs, which corresponds to opening public places, or places that a lot of people could come into contact with each other, let's say schools. So if you use compartment-based models which have this random assumption, a structure assumption to predict what would happen, you're significantly underestimating how bad things would get, basically. Another assumption that these compartment-based models, classic ones, have is that they often consider closed population. But we know that we live in an interconnected world, and there is a lot of movement between the populations. So how can we incorporate that into the model? We proposed a very simple modification to the classic model that has these inflows, and then these could be estimated from the flight network data, which is available online. And what we showed here is that if the model was incorporating these inflows, we could have predicted that we have an epidemic on hand much sooner, before the border closure. And basically, moving forward, this model could give you a risk estimation for opening flights to different specific countries based on their stats currently. Right, so moving forward to the second application, which is uncovering organized crimes. This is around human trafficking, which might not be as well known as the COVID, but unfortunately it's a very large scale problem. So I'll start with some just statistics onto scale and scope of the problem, and then I'll present the solutions that we are working on. So there are more than 20 million victims worldwide, and majority of them are women. A majority are victims of sexual exploitation. And if we look at Canada specifically, there are 93% of the victims are actually Canadian citizens, and the number of police reported incidents of human trafficking is on the rise. And between the victims, a majority are young women, and 1 in 4 is underage. If you're interested to know more about the statistics, there is trafficking in-person reports from UN, and also specific to Canada, I've included a link here. The good news is that there is a recent awareness into the problem in Canada. So We have specific task forces initiated to combat human trafficking across different provinces. There's a national strategy to combat human trafficking, but this is still very much a problem, and we need to develop solutions to help with the problem. So in our group, we are focusing on a specific part of the problem, which we think could be automated. And that's specifically given the fact that majority of these sex trafficking victims report of being advertised online. How can we monitor online escort markets to detect human trafficking? So these online markets happen in used to happen mostly on classified advertising websites. Some of them are moving to social media as well. But at least up to 2 years back, Backpage was the main hub for escort advertisements, which is basically a classified advertising website similar to other classified advertising websites. You can see that you have locations in different cities in the United States and Canada. And here we wanted to see how prevalent the problem is. So we had access to 3 months of data from a national human trafficking hotline in the US, where people call and report a phone number. And we wanted to see if there are ads posted on Backpage that have that use these reported or suspicious phone numbers. And you can see that, yes, there are, and it's almost widespread in all the states, and also present in the provinces in Canada, although it's a US hotline. So in 2018, Backpage was seized by the FBI, and they actually put in place laws to help fight online sex trafficking. But the problem is that what that caused is just the market to move to new web pages. So specifically here, we were monitoring 2 Canadian websites that could be alternatives to Backpage. And you can see that after the shutdown of the Backpage, you see a surge in the traffic in these 2 alternative websites. So looking at the human trafficking investigation, we can consider 3 steps that go into the process. The first thing is to find a lead to follow. For example, you can start with a phone number that is reported to a hotline. The second step is to start to gather all the information and connected ads to that lead. For example, all the ads that use that phone number, all the ads that use strikingly similar wordings in their advertisements to the ads that use that phone number. If there are other ads that seem to be taken in the same place or same room. We collect all this information, and if the connection is clear, and if we see evidence of something organized going on, then law enforcement would invest time and resources to verify the case and do target identification, which is a very lengthy process. It takes from months to years to finish. So what we are trying to do is to make the first 2 steps automatic, or help to speed up the first 2 steps, so that we get cases that are as high quality as possible. And the key takeaway or point that we focus on is that trafficking is organized. If we look at the average case, it usually involves 4 to 6 victims, but we have much larger rings as well, international rings. But the average one is that you have a small number of victims, and often the case is that they don't post the ads themselves, and even they might not know the exact wording that used in the advertisements. So these are two example cases in Canada in 2014 and 18 that the traffickers were victimizing underage underage girls, and they had a trafficking ring, and they used online ads to advertise the victims. And that's actually that's one of the drawbacks of these platforms, because they provide a very easy way for these traffickers to stay anonymous, operate on a wider geographic range, and lower their risks. And that's actually that is correlated with the increase in the number of human trafficking cases as well. So to design solutions for combating human trafficking, we have multiple projects in the lab. The first one is how to find and spot this kind of organized activity and characterize them. The second one is how to do name entity extraction from this data, because all the information is put in place assuming that the machine is reading it. So it's masked, it's not easy, you cannot use something off the shelf to extract information. How to actually crawl and store the data in a useful format. How to match the background of the images. This is also a non-trivial task. There are a lot more works that you can find on face detection or face recognition, but not much on background matching. So one of my students is using a recently released public data set to try to detect images that have been taken in the same hotel room. And then this would be integrated to the analysis that we are currently doing, and is mostly text-based. And another student is looking at how can we design human-in-the-loop solutions for case building. And it's based on a prior work where the main idea is that you start from a lead and you want to add things that are relevant to the case. The system could suggest things to you based on the cases that you have built so far, and where and the things that are included in the case at this point. So just zooming in on the first project, which is finding and characterizing microclusters. What does it mean is that it's a fully unsupervised method, and it's very powerful actually. So a majority of related works actually for detecting human trafficking are supervised solutions, which are not ideal for this case because labeling this task is very hard and noisy. So if we need if we have a method that relies on labels a lot, it wouldn't be it cannot adjust to the changes in the patterns of how these traffickers are using these platforms, and also we don't really have any labeled data set that is of a good quality for this task, and it's not feasible to design one. So what we do here is that you have given a large number of ads, and we want to find clusters or microclusters of a couple of ads that seem to be posted by the same person. We want to rank them based on how suspicious they are, and also show why we think these are connected to each other, and also filter out anything that is irrelevant. So what we have in the bottom is actually two results of our microclusters or cases that our method is able to discover. The one on the left is from historic data from Backpage, and that's actually confirmed, one of the few confirmed trafficking cases that was in court only last year. And the data that we have is from 2015. So that shows you how long it could take for a case to be confirmed. The one on the right is from the live data that we are crawling from Canadian websites. And what we actually observed in this data, which is very surprising, is that you have a lot of different types of activity beside just escort ads and human trafficking. You have a lot of scammers, a lot of spammers, and it's not clear why we have these ads, but it's important to be able to filter them out, because consider that even without these, it's hard for an investigator to go through this volume of data. Let's say you have 100,000 ads posted each day, but then a lot of them are smoke screens. So it makes the manual procedure almost impossible. So what we did is that let's look at these microclusters and try to detect different types of activity. And there is actually different types of activity. It seems to be that are clustered together, which we call MOs. And we are working toward automatic spam detection right now to be able to filter out microclusters that are not likely to be involved, to be involved in trafficking. In follow-up work, we also showed that the technique that you developed to detect these microclusters is generic. You can actually use it to achieve almost the state-of-the-art in identifying Twitter bots. So basically, in the same way that the ads that are posted by the same pimp are similar or use the same patterns, the tweets that are posted by a bot are also show similarities. So we can we showed that the results of this method, which is again fully unsupervised, is on par with the supervised approaches that are proposed for the same task. And we are working, so it's important to mention that we have collaborators in CMU and also Marinus Analytics, and we are working closely with them for the human trafficking project. Marinus Analytics have been active in the area of human trafficking for a long time, and they have solutions to help law enforcement to tackle this problem, and we are trying to see how can we incorporate the techniques that we develop into their solutions. So moving to the last project, which is around analyzing interconnected discussions online, I want to just highlight a few quickly a few projects that we are doing to address the basically the volume of data that we are all subject to on social media, and the misinformation, fake news, and how to basically make sense of this data. So where the project started is actually last year around the federal Canadian election, and we were interested to see the activity of the users that are engaging in the discussion around Canadian politics, and see if we detect microclusters or coordinated groups. Could we discover anything interesting? So basically, a lot of works that you see on understanding posts on the social media only focus on the content. For example, what are the content of the tweets? But in this project, we wanted to say that you actually want to look at how people are connected to each other as well. And that would help us to spot coordinated activity better. So if you have a set of, let's say, troll accounts, they might follow each other as well to try to just boost boost each other's and put out the message that they are trying to put out better. Right, so here the groups that we discovered were much more likely to be suspended by Twitter, the users in those groups, compared to if you only focused on the connections or the content. And also the hashtags that we detected as the main interest of these groups were also linked with the misinformation campaign. As a follow-up of this study, we now have multiple projects and a very active collaboration with people in political science. And specifically, we are looking at how to measure polarization and how to detect polarizing activity in social media around political events. To wrap up the presentation, I want to quickly mention that this talk is part of a series that aim to collect money for TechAide, which is a nonprofit dedicated to fight poverty and social exclusion. So if you are interested to support them to fight poverty and social exclusion, please consider donating, and the donation link is in the chat. Thank you for listening.